All right, this is the second video in a series of 4 for the Q1 Benchmark Study Guide. So I'm still in the same spot right here, just going to start a new video. So these will be through 7 through 14. All right, here we go. Number 7. Honestly, I think 7 through 14 is what we just covered, the scientific notation, the exponents, things like that. So this should be pretty fresh on everybody's mind. The distance from Denver to Philadelphia is approximately 1.728 times 10 to the third miles. The distance from Denver to St. Louis is 8.5 times 10 squared miles. Which operation would you use to find the distance from St. Louis to Philadelphia? So let me do this since I've got the magic of my device here. We'll go Denver to Philly is 1.728 times 10 to the third miles. So Denver all the way to Philadelphia is there. The distance from Denver to St. Louis, so Denver to St. Louis is 8.5 times 10 squared. So Denver is here, St. Louis is here. Okay. Which operation would you use to find the distance from St. Louis to Philadelphia? So this is what we are trying to find. What I would do is I would take Denver to Philadelphia and I would subtract Denver to St. Louis because it looks like the only thing that we're trying to find there is that purple on the right. This is going to be subtraction. This is a difference problem. You're trying to find the difference in those two distances. So I would take Denver to Philadelphia minus Denver to St. Louis. But we don't have to. The question just says which operation would you use? So just pick the operation. That's it. Number 8, simplify. So this is a multiplication problem. So what I'm going to do is rewrite this, if I can find some space, as 1.67 times the 3.45. I had a lot of students today trying to get the same exponents. Remember that is only with addition and subtraction, not with multiplication and division. So what I'm going to do here is take my 1.67 times 3.45, which gives me 5.7615 times whatever 2 plus 3 is, so times 10 to the fifth, that's a 5, fifth power. And I'm actually, I guess, right over it. Yeah, so it's going to be C. That is the correct solution. You can look at so sometimes it helps to kind of eliminate what you know is incorrect. If it wants us to put this in scientific notation, D is definitely out because 57 is not between 1 and 5. So sometimes that helps you eliminate some of the choices, narrow down what you got available to you. So there we go. All right, next one. Simplify this. This is an addition problem, so we need to have the same exponents. So what I'm going to do is increase my 3 by 1, which means I must decrease my decimal by 1 place value. So I'm going to rewrite this. Actually, I'm going to rewrite it above. So this would be 0.28 times 10 to the fourth plus 4.5 times 10 to the fourth. By us getting those exponents to be the same, that's essentially like we are lining up our decimals. Now all we have to do is add. So I will. The 0.28 plus 4.5 gets me 4.78 times, you'll just keep that 10 to the fourth power the same. So 4.78 times 10 to the fourth power. Okay, well, this is in standard form. So what we'll do is take this 4.78, use the exponent, right? So it's an exponent of 4. So we will move our decimal 1, 2, 3, 4 places, and fill in those blank spots with zeros. So this would be rewritten as 47800 47,800. A is going to be my solution for number 9. Number 10. Object A weighs 3.2 times 10 to the 5th milligrams. Object B weighs 2.4 times 10 squared milligrams. How many times heavier? This is division. Okay, anytime you see how many times heavier, that's division, is object A, so that's going to be the numerator, than object B. So I'm going to take object A, which is 3.12 times 10 to the 5th power, over object B, which is 2.4 times 10 squared. The way that I showed you guys how to do this was to split up what you can divide, so those front factors, the constants, if you want to call them that, split those up with the factors of 10. Here's what I mean. I can show you better than I can tell you. It's been a long day. So this is what I mean. We can divide the factors of the 3.12. So 3.12 divided by 2.4, that gets me 1.3. And then remember, when we are dividing powers with the same bases, just subtract their exponents. So this would be 10 to the 3rd power. 5 minus 2 is 3. So it does say scientific notation. Okay, just checking to make sure. It would be 1.3 times 10 to the 3rd power. All right, that is number 10. Number 11. What number makes the given expression a true statement? So when we have the same basis here of 6. We are multiplying, so what we're going to do with our exponents is add them. So what goes through my head is this: 5 plus what number equals 12? A couple different ways you can think about that. If you want to solve an equation, you can, but I would just kind of think, what is 12 minus 5? What's that difference there? It's going to be 7. 7 is the missing number that we have. So D is the correct solution for number 11. Number 12, simplify. So as I said on one of the earlier questions, when we have powers with the same base and different exponents, we subtract them from the top down. What that means is this is going to be 3 to the 2 minus 7 power, which then will give us 3 to the negative 5th power. Anytime you have a negative exponent, think fraction. Okay, think fraction. So we need to take this 3 to the negative 5th power and flip it to where it's in the denominator, which would then be 1 over 3 to the 5th power. And looking at my solution choices here, the 3 to the 5th power is not a choice, but remember, 3 to the 5th power means 3 times itself 5 times, which will give me 243. 1 over 243, so that would be A. Okay, A is what we're looking for there. Number 13, just a couple more left on this video. Number 13, simplify. Now, I taught you guys this, okay? I taught you that, if you have something being raised to a power like this, distribute all of the exponents. What I need you to realize too, though, is that this can be simplified. I would try to simplify that before I distribute that too, because you're going to have way less things to distribute, at least I think. I don't know. We'll see. So I'm going to rewrite this. 4x to the 5th, y to the 0 over 2x cubed. This is all being squared right here. So kind of break this down. What can we do here? Well, 4, so let me draw this. 4 divided by 2 is 2. So I'm going to go ahead and have that 2 there. My x's, I've got 5 in the numerator, 3 in the denominator, so you can take 5 minus 3 to get 2. So this would be x squared. And y to the 0 power, that's just 1. So you can put a 1 in there if you want. You don't have to. Maybe for the sake of this video, I will. But you technically don't need it because 2 times 1 is just going to get you 2. But I'll do this. That's fine. Okay, keep it squared. Exponent on the 2 is 1. So you can distribute that. So one more step, just because this is the walkthrough video. What this means is we can take 2 to the first power, square it, times x to the second power, and square it, which this would be 2 squared times x to the fourth power. Anytime you have a power raised to a power, you multiply the exponents. So this is going to be 2 squared x to the fourth, which 2 squared is 4. A lot of work, I know. 2 squared is 4, so this would be 4x to the fourth power. So D is the correct solution for number 13. Okay. Number 14. Select all of the expressions that are equivalent to 1 over x squared. So I'm actually just going to simplify what I can down here and see what shakes out. Since a is x to the fourth times x to the negative 6, you can add these exponents. So this would be 4 plus negative 6 would be x to the negative second power, okay? Which, if we're trying to get all positive exponents, like I talked about on one of the previous ones, when you have negative exponents, flip them, okay? So you're going to use that negative exponent to where this becomes 1 over x squared, which is what we were looking for. So A will work. It does say all of the expressions, so I'm going to keep going on this. X to the negative second power, we literally just got that on A, so that does equal 1 over x squared, which is what we're looking for. Okay. For C, we're going to subtract x to the 5 minus 7, which is x to the negative second power, and we did just, for the past couple, figure out what that is. Once you have x to the negative second power, you flip it. C also is a solution. D is not a solution because that is just x squared, and that's it. Yeah, so that's not the same as 1 over x squared. But that is 7 through 14. That is video 2. I'm going to upload it and get to work on video 3.